Good evening, everyone. In the last class, we have discussed what is physics. So, as already written here, it is thinking or imagination of natural phenomena, that is plural of phenomenon. We do subtle, precise and accurate experiment in the laboratory to express the result in terms of one of the simple mathematical relation by means of, look at here, expression, identity, equation, inequality and inequation. So we have 5 ways to express the result what we have been obtained by the subtle, precise and accurate experiment in one of the 5 ways. So now just we are going to discuss the definition of physics. So in the last class we have been seeing the minute differences among hypothesis, postulate, law and definition. One genuine question is that what is law? Is law persist? For always? The answer is, in general, yes it is. But in the past, only few cases, the law has been proved wrong. It is not worthy to say wrong, but still we have to say wrong. As we all know, before Clerk Maxwell, every one of the scientists, every one of the thinker, every one of the physicists are well aware about that there is a ether medium in the outer space. That is the wave phenomenon. But later on, as per Maxwell's law, Maxwell's finding, this notion of presence of ether in the outer space is proved wrong. Now in the second instances, it is believed that in case of the crystalline solids, they have certain repeated pattern. However, in terms of basic units, simple cubic, body center cubic, CCP, cubic closed packed, and SCP, hexagonal closed packed. These are the unit, in fact a unit cell, and the repetition of these cells makes the particular crystalline solids. However, we also know the amorphous solid as well. The amorphous solids has no any definite repeated patterns, so it is called isotropic, but the crystalline solid is called anisotropic in nature. But as per Nobel laureate Dan Sechsman, there is Kawasaki crystal in which repeated patterns is not found, but still it is crystalline solid. So every one of the crystalline solids has repeated pattern, repeated unit is proved to be wrong. And the last instance was as per BCS, Barden, Hooper, Schrieffer. These three scientists has been proved that superconducting material never exists beyond 30 to 40 Kelvin temperature. What they said. But later on, as per Razique, it is proved that the superconducting material may exist up to roughly 7 times of 30 to 40 Kelvin temperature. So these are few instances in which the exist law proved to be wrong. But in many occasions, it is found that the existed law has been modified several times. For instance, look at here. So as we all know, the linear momentum of a particle or system of particles P is equal to mv, and the net force acting on an object F is equal to mass times acceleration. This law is totally based on Newton's finding, Newton's second law. However, time rate of change of linear momentum gives you force and hence mass times acceleration. So these two laws and also too many laws has been modified. Why it is modified? That's the genuine question. Because of the fact that these laws are applicable when the speed of the particle or our system is not comparable to the speed of light. As the speed of the particle or of an object is comparable to the speed of light, then these two laws, in fact many more, but here we are focusing on these two, need to be modified. So just in this class we are going to learn how this modification is done. For this, we have to study certain transformation. So there are too many transformations. Transformation due to rotation of axis, transformation due to reflection of the coordinates, transformation due to parity transformation. However, this transformation we will see in the chapter of vector in this course of mathematics for physics. But right now we are going to study Galilean transformation and as well as Lorentz transformation. However, both for the coordinates as for the velocity, and then we will see how this linear momentum and the force need to be modified when the speed of the object or the particle or the system is comparable to the speed of light. So let us start with the Galilean transformation and then Lorentz transformation. Look at right now. So firstly we are going to study what is called Galilean transformation, and then we will study Lorentz transformation. So here firstly Galilean transformation. Galilean transformation. Galilean transformation. What is this? So suppose here we have a frame S and here the frame S prime. So might be here say x-axis, y-axis, and here is the z-axis coming out of the board. So taken here is a z-axis. Now on the same line here x prime, y prime, here is the z prime coming out of the board, whiteboard in fact, the z prime. Now our only criteria is that this two frame has relative velocity with respect to each other. However, one of the frame may move in any fashion, but for simplicity we consider that the frame S prime is moving parallel to the x-axis. If this frame is moving this way or that way, or here in that way, into the board, out of the board, upward, downward, in any way, so transformation is applicable. That will give you cumbersome calculation to understand the Galilean transformation. But right now, for the simplicity, we assume that the S prime frame is moving parallel to the x-axis, say with the speed v. So here is the say origin O, here the origin is O prime. Now, firstly we assume that at the beginning the O prime and O coincides. However, here the speed of the frame S prime is not comparable to the speed of light. Then it is worthy to assume that the time measured in S frame, or we place a clock in the S frame and we place a clock in the S prime frame, almost give you same time. This is only criteria is that when this speed is comparable to the speed of light, then we will see both the clock placed in S and S prime frame not give the same time. So that is why I am telling you here the speed of the prime S prime frame is v, which is not comparable to the speed of light, means 5, 10, 20, 100, 1000 meters per second at most. So after time t, suppose at t is equal to 0, in fact t prime is equal to 0, both are the same time. So this O prime is O here, and after time t or t prime, so all the time we take say t is equal to t prime. So after time t, this origin O has been moved with say v into t. Suppose here is the particle p. We want to relate the coordinates firstly with the x coordinates. How one can relate it? A very simple way. So let us look here. This is say x prime here. Now from this frame supposed to be at rest, and this frame is moving with respect to S frame with the speed v. If you are sat on the S prime frame, then it seems to be this frame moving towards left. So that's altogether different issue. So just I am here and watching S prime is moving with speed v parallel to the x-axis in right way. So here is the x. Look at here. Here x. So from figure it is very clear. From figure we see that x is equal to vt plus x prime. So this implies x prime is equal to x minus vt. So what about, because here is the coordinates x prime, y prime, z prime in S prime frame, and from S frame the point is same, x, y, z. So motion is only parallel to the x-axis, so y prime, z prime will not change. So here y prime is same as y, z prime is same as z, and we have already mentioned that these two clocks measure the same time. So t is prime is equal to t. So these are the transformation coordinates as per Galilean, but only when this speed is not comparable to the speed of light. But right now we are going to study if this S prime frame moving with the speed v, which is compared to the speed of light, then how this transformation, or you may say how these coordinates are related to each other. So now our task is this. So now the second one we are going to study here, the Lorentz transformation. Lorentz transformation. So for this so again we have to take the two frame, S frame and S prime frame. Again here x, y, and here is z coming out of the board. Here is the x prime, y prime, and here is the z prime coming out of the board here, like that. Or this is the S prime frame which is moving with respect to S frame in right way, as here say with the speed v, but this time this speed v is comparable to the speed of light. Then how the coordinates are related, just the matter of interest right now. So here is the say p, point is p is here, coordinate here is x prime, y prime, z prime, and at the same point here the coordinate in the S frame is x, y, z. So these coordinates, how they are related. So to understand this one, we have to take the help of postulate of theory of relativity. Now the relativity theory comes into play. So what are the postulate of the theory of relativity? So firstly we have to mention this. So here is the number one, we call it first the laws of physics. Laws of physics, or the form of law of physics. The form of law of physics are same in all inertial frame. All inertial frame. frames. Number 2, speed of light in outer space, that is in vacuum in if measured from every one of the inertial frame frames comes out to be same, that is constant C, which is equal to 299,792,458 meter per second. And the number 3 postulates. Number 3 postulate here, homogeneity of space and time. Homogeneity of space and time. And number 4, isotropy of the space. These are the two postulates is the main postulate of the Einstein theory of relativity, and we have to mention these two, homogeneity of space and time, and the number 4 is the isotropy of the space. So under these 4 assumption, you may call it postulate, we are going to find the relation between x prime in x, y, z and t, y prime, z prime and t prime. Just we are going to find it out. So look at here right now. So how these coordinates are related, just we are going to find the relation. So firstly, here x prime is related as a11x, a12y, a13z, a14t. But this time, when the speed of S prime frame with respect to S frame is v, which is comparable to the speed of light, say 0.6 c, 0.5 c, 0.7 c, 0.8 c, etc. Then if we place a clock here in the S frame and we place a clock in the S prime frame, then these two clocks not providing same time. The clock S prime, or the time measured from S prime frame clock, is not same as the time measured from the clock which is placed in S frame. So that is why these two are also related. So here y prime comes out to be a21y, a21x, a22y, a23z, a24t, z prime, a31x, a32y, a32z plus a3233z, a34t. Now here the t prime A41 x, A42 y, A43 z, A44 t. So here look at these results are related with the linear power of the variables x, y, z and t. So we have to investigate why these coordinates, say x prime, y prime, z prime, t prime are related with x, y, z and t of the s prime coordinates with the linear power. We have to investigate it. Just I am going to investigate it. But right now here A11, A12, A13, A14, A21, A22, these are the arbitrary constant. I have told you in the earlier classes, constant are of two types, numeral and arbitrary. So here the number is not given in terms of numerals. So that is why they are known as arbitrary constant. Look at here 16 arbitrary constant, and we have to find it out these coordinate, this arbitrary constant, and then back to the relation, and hence we will get the relation between x1 and these coordinates y prime, z prime, t prime, not x1, x prime to that. Okay. So here we have to worthy to mention here, say z prime, t prime. Here is the z and t, here the four coordinates. Three coordinates x, y, z as we know as usual. The fourth coordinate time coordinate. So altogether we have to take care of t prime and t, because these two clock will not give you same time. So just we are going to investigate it. Firstly we are going to investigate it. Why not x square, y square, or x cube, y cube, or t cube, t square, like that. So to understand this, we have to take the isotropy of the space. How? Suppose we have to find the length of the rod. So if we say this is related to say x square, suppose x square only. To understand this one, look at here. If we say x prime related to say x square, just I am going to clear that why not x prime is related to the other than linear power. So that is why x prime taken as x square. Maybe other all the other coordinates supposed to be a 0. Let us consider, because if you say ax square plus bx plus c is the quadratic expression, b, c may be taken as 0. So ax square may be taken as a quadratic expression. That is why I am saying like that. So suppose x1 is equal to 1, x2 is equal to 2. Two values. Say x1 is equal to 3, x2 is equal to 4. As per x1 prime, x2 prime will comes out to be. So here say here the coordinates a11 taken as 1. You may take it here or you may take it 1. If you do not take it 1, you may write like this: x prime is a11 x square. So if here x1 is equal to 1 and x2 is equal to say 2, so here x2 prime minus x1 prime comes out to be thrice a11. Now if you take like here x1 is equal to 3, x4 is equal to say 4, still is the 1 unit. So but what about the x4 prime minus x3 prime? So again this comes out to be, so x2. So now here is x2 prime minus x1 prime comes out to be, so 4 just 16, put here 4, 16, 3, 9, 7 a11. However, difference is 1 here, also a difference is 1 here. But look at the distance from S prime frame here is 3a11, that's okay, but it's not the same. So it means a space is not isotropic. What is the meaning of isotropic? Isotropic means in any direction you measure the same environment. So it is not so. So the isotropy of the space has been violated. That is why the linear power x power 1, y to the power 1, z to the power 1. No other than 1 power is allowed. If so, then isotropy of the space has been violated. That is why. So I have been clear here why the power 1 1, it means the linear relationship exists among these coordinates S frame and S prime frames. That is why. So now the task is that how one can find these what is called the arbitrary constant. There are altogether 16 arbitrary constants. Just we are going to find out. Now to find these relations, firstly we take here at the beginning O prime coincide with O, and at the same time x prime and the x axis coincides each other. So at the beginning t is equal to t prime is equal to 0 to take, there is no any harm of generality. After that, so t prime t is related like here, that's okay. So look at here, so this axis is coinciding each other. So if we take the points on x axis in S frame, so y0 and z0, take the points on the x prime axis which is coinciding with the x axis, then y prime z prime comes out to be 0. If we take these x if we take the points on x axis, then y0 comma z0. If we take the points on x prime axis, then y prime 0, z prime 0. This permits us. So firstly we are taking y prime and z prime here. So firstly we are taking to here y prime z prime. So if this things happen, then what will happen for this one? Then y prime is taken as A22y plus A23z. So this A21 and A24 must be 0 because we have taken the point on the x axis. That is why. On the same line for z prime, here is what is here? A33z. So here firstly A32y plus A33z. So here A31, A34 comes out to be 0 because of the fact that we have taken the point on x axis and on the x prime axis, and these two axes are coincidence. That is why. So here now we have to find A22, A23, A32, A33. So firstly we try to find say A23 or you say A32. For this what we have to do? We have to transform the coordinate of xy plane, that is z is equal to 0, over x prime y prime plane, that is z prime is equal to 0. If we transform this way, then A32 and A23 comes out to be 0. Must be 0. So what we are going to write here? If we transform what? XY plane, that is z equal to 0 to x prime y prime plane, that is z prime is equal to 0, then there must be what? A320, A230. A23 comes out to be 0 and A32 comes out to be 0. That's fine. Now what we have left? We have left now here y prime is A22y and z prime is A33y. Now our target is to find A22 value and A33 value. How is it possible? Now look at right now. Now what we have to do? We have to take a rod of unit length placed parallel to y axis in S frame, which is supposed to be at rest. Then y is equal to 1. So now what is the y prime? Y prime is here z A33, sorry, here A33z. Firstly we are taking this one, and as we have got A23 is equal to 0 and A32 is equal to 0, then back these two values in y prime equation and z prime equation. Now what we got, look at here, this implies y prime is equal to A22y and z prime is equal to A33z. Now our task is that to find the value of A22 and A33. How can it be possible? For this, we take a rod and placed parallel to the y-axis in S frame, and the observer from S frame, say, measure its length 1 unit. Then the observer from S prime frame measure the same length as A22. Now look at the board. Means it gives y prime is equal to A22 into 1. Now we brought very same rod at rest in S prime frame, and this rod is also placed parallel to y prime axis. Then the observer from S prime frame measure the same length 1 unit. Then the same observer, or maybe the other observer, measure the same length from S frame as 1 over A22. Look at on the board. Y is equal to 1 over A22 y prime, that is 1 over A22 1. These measurements of length from S and S prime frame are reciprocal in nature. However, these two measurements must follow first postulate of theory of relativity. Otherwise, there would be an asymmetry in these two frames S and S prime. And also, these two lengths must be identical. Otherwise, there would be the given two frames are not identical physically. For this, these two lengths must be identical or equal. Look at the board. A22 into 1 is equal to 1 over A22 into 1. This implies A22. This implies A22 is equal to 1. Similarly, we may find A33 is equal to 1. Now, we back these two values in y prime equation and z prime equation, then we get y prime is equal to y and z prime is equal to z. Now, we look at t prime equation firstly and then x prime equation. So, t prime is equal to a for 1 x plus a for 2 y plus a for 3 z plus a for 4 t. For the symmetry reason, t prime must be independent of y and z. If we place clocks symmetrically with respect to yz plane, that is such as at plus y and minus y or plus z and minus z, then these two clock provides different values of time for the observer of S prime frame. Then what we conclude? Then these different measurement of time contradicts the fourth postulate, the isotropy of the space. That is why we must have to take t prime independent of y and z. For this, we must conclude a for 2 is equal to a for 3 is equal to 0. Then t prime equation reduces to a for 1 x plus a for 4 t. Now we have to think of x prime equation. x prime equation, that is x prime is equal to a11x plus a12y plus a13z plus a14t. To find the values of arbitrary constants involving in x prime, look at s prime frame is moving towards right with speed v. Then we think before crossing the s frame, because we have already assumed that s frame is static. Suppose s prime frame is moving in this way, right way with the speed v, coinciding x prime axis with x. Then as O prime crosses the O, take it here 0, 0, 0. This is also 0, 0, 0. We take x prime is equal to 0 at the moment when it crosses O, because x prime and x axes are coincidence. Then x prime is equal to 0 is equivalent to x is equal to vt. Because moving with the speed v, we are taking this measurement from the s frame. So after time t, speed is constant, then we may apply dvt relation, that is distance is equal to speed into time when speed is constant. So that is why. And obviously the x prime we have taken 0, which is at the origin, where automatically y, z coordinates are taken to be 0. That is, here these two middle term disappear. Now what we have left? Look at here, x prime is equal to a11 x minus vt. Look at here, all the time x equal to vt give you x prime is equal to 0. That is, it is consistent with that x prime coinciding with the x, and x prime is equal to 0 all the time. So this is the reason. So this implies that a14 is equal to minus v a11. Now we summarize all four equations at a glance. Now look at on the whiteboard. Here x prime is equal to a11 x minus vt, y prime is equal to y, z prime is equal to z, and t prime is equal to a41x plus a44t. Now what remains? To find a11, a41 and a44. For this, what we have to do? Again we have to think s prime frame just crossed s as it looks, but think s prime is left of s. On a similar manner, x prime coinciding with the x it is moving, S prime is moving. Once it crosses the origin, what does it mean? It means that O prime coincidence with O. And at the same very moment, we place point source of light. Now, again we have to think the fourth assumption or the postulate of theory of relativity. That is, space is isotropic in nature. Then this point source spreads energy in all possible directions equivalently. And we all know that the wavefront spreads from the origin of S frame and S prime frame at very same moment, means the radius of spherical wavefront increases with the rate of c, that is the speed of light. We all know speed of light c is equal to 299,792,458 meter per second, irrespective of the inertial frame from which this value is measured. This is the second postulate of theory of relativity. Just we are going to use this one. So, O and O prime taken as center of the sphere, or you may call it the center of the spherical wavefront. Then it gives, look at the board. X square plus y square plus z square is equal to c into t whole square, and x prime square plus y prime square plus z prime square is equal to c t prime whole square. Now take it equation number 1, 2, 3, 4, 5 and 6. Now from equations 1, 2, 3, 4 and 6, comma, we get what we get. Look at here, x prime is equal to that much. So A11 x minus vt whole square, y prime here same as y, y square, z prime is equal to z, z square. This is equal to here c square and t prime. From for here a for 1x plus a for 4t whole square. Now just we want to write as, so look at here, if we expand this one, we get x square plus v square t square minus twice x vt. Expand this one, a for 1 square x square plus a for 4 square t square plus twice a for 1x into a for 4t. So here a11 square, here the x square term from right side, bring it to the left side. So it becomes here c square a for 1 square and then x square. Y square, the only terms in the left side, y square. Z square, the only term. Now here the minus sign, twice a11 into v. We preserve xt from here, plus c square, in fact twice c square a for 1 into a for 4 xt, we have to take common, x into t. Look at how, because here the plus, because a plus b whole square, a square plus b square plus twice ab, the plus twice ab term we have to bring on the left hand side. So the minus, and here the on the left hand side already minus, the minus has been taken out common. So this is the case, is equal to, now here in the first term we have a11 square v square t square. So we have to write here a11 square v square, preserve here t square. Now here, so this term is a plus, on that side it becomes minus. So now here plus c square a for 4 square and t square is taken as common. Now taken as equation number 7. Now we compare. We compare equations 5 and 7, comma, we get. What we get? Look at here. Here x square coefficient is 1, here is that much. So a11 square minus c square a for 1 square is equal to 1. Look at here. Coefficient of y square is 1, here also 1. So it identically equal, 1 is equal to 1. So coefficient of z square is 1 here, and here also coefficient of z square is 1. So is also identically 1 is equal to 1. Now here on the left hand side there is no term containing xt, but here is the term containing xt. Look at here. Then minus twice a11v plus twice c square a for 1 a for 4 is equal to 0. Now look at here, in equation number 5, right hand side, the t square coefficient is c square. Here on the equation number 7, coefficient of t square is that much. So c square a for 4 square minus a11 square v square is equal to here c square. Now we got a set of 5 equations, but these two are identically equal. So these two equations are valid for any values of a11, a41 and a44. So equivalently we have left only 3 equations here, this, that and that. And look at 3 equations, 3 unknown. Then the necessary condition of finding solution is fulfilled. Now, it is matter of interest that whether it may be sufficient or not. Then we try to solve these three equations to get A11, A44 and A41. So quite easily we are able to find the values of these arbitrary constants, as here look at A11 is equal to A44 is equal to, comes out to be 1 over square root of 1 minus V square over C square square root, and A41 comes out to be minus V over C square whole over square root of 1 minus V square over C square. Now we have to back these values in the reduced form of the equation, then we will get the transformation equations. Look at. After backing these values, we may get x prime is equal to x minus vt over square root of 1 minus v square over c square. Y prime is equal to y, z prime is equal to z, and t prime is equal to t minus xv over c square whole over square root of 1 minus v square over c square. So our task is over. We got the transformation equations, that is the coordinates of S prime frame in terms of the coordinate of S frame. Now a genuine question is that, are we in a position to find S frame coordinates in terms of S prime coordinates? Answer is yes, and with great ease. Let us see how. Only criteria is that we have to change primed coordinate to unprimed and unprimed to prime, and in addition to that, the frame speed v is replaced by minus v. Why? Because if we sat on the S prime frame, then the S frame seems to be moving towards left. That is why. Now transmit it. So here x prime becomes x prime minus v is replaced by minus v, so becomes plus v, and t as a t prime, because t is a coordinate now, because this time coordinate is also related, means when the speed of the S prime frame is comparable to the speed of light, then if we place clocks in respective frame, then these two clocks will not give you same time. That is why. Over square root of 1 minus v is replaced by minus v, because a square, we all know, a square of negative real number is also positive. So here it is unaffected, v square over c square. Now y becomes y prime, z becomes z prime, and t prime becomes t, and t prime here minus x is x prime, v is minus v, so becomes plus over c square whole over square root of 1 minus v is replaced by minus v, it is not affected, so it is v square over c square. So these are the transformation equations of S frame to the S prime frame and S prime frame to the S frame. Now again a genuine question is that, is there any need of this transformation? We call it Lorentz transformation equations, but in fact the name of these equations is given by point care, but still these equations are known as the name of Lorentz and we call it Lorentz transformation. When we apply in the speed of the frame, look at here, is comparable to the speed of light. So now again comes to the point, is there any need in the higher secondary physics course? Answer is little bit or may not be, but in undergraduate physics and the postgraduate physics we may find these things quite often. But we studied keeping in mind that when we will take up magnetic field chapter, then there a few problems may be solved quite easily by such transformation equation, but exactly not these are, but in terms of electric field, magnetic field transforms equation in S and S prime frame. So such equations provides great ease to solve few problem of higher secondary physics of magnetic field. That is why just we are well acquainted of such transformation equations. And also we all know that physics is a fun, so it will provide you a lot of fun even in the higher secondary physics. So I think enjoy this transformation. Hopefully we will take up in the next class the velocity transformation. Before that we will discuss the concept of relative velocity and Galilean transformation with respect to velocity as well. Thank you.